Dear students, welcome to Operating System video lecture session. In continuation to the previous lecture video, we will continue with inter-process communication. Let me share the screen. Inter-process communication. Inter-process communication, it's a process executing concurrently in the operating system, maybe either independent process or cooperating process. A process is independent if it cannot affect or be affected by other process executed in the system. Any process that does not share the data with any other process, then it is called as cooperating process, right? So any process that shares data with other process is cooperating process. There are several processes that include the sharing data. So reasons for cooperating process. So there are several reasons for providing an environment that allows process cooperation. The first one is information sharing, computation speed up, modularity, convenience. What is information sharing? Since several users may be interested in the same piece of information, we must provide an environment to allow concurrent access to such information. Coming to communication speed up. So if we want a particular task to run faster, we must break into subtasks, each of which will executing in parallel with others. Notice that such a speed up can be achieved only if the computer has multiple processing cores, that is multi-core systems. Modularity. We may want to construct the systems in modular fashion, dividing the system functions into separate process or threads. Then that is modularity. This modularity we will discuss in the further chapters. Convenience. Even an individual user may work on this many tasks at the same time. For instance, for example, say user may be editing, listening to music or songs, and compiling some parallel processes. Then it is called as convenience. That is, you can do multiple tasks at a time. So this cooperating process needs inter-process communications. So there are two models of inter-process communications. There are one is shared memory and message passing. Inter-process communication can be done in shared memory and message passing. In the shared memory model, a region of memory that is shared by cooperating process is established. Process can then exchange information by reading, writing data, to the shared region. So in the message passing model, communication takes place by means of message exchange between the cooperating process. So you can see here. So this is message passing. You are exchanging the messages. Right. So this is message passing, and this is shared memory. So you are sharing the memory here, right? Here it is message passing. This is process A, process B. So there are some message 1, message 2, message 3, and so on, message N. These are the message queue, and these processes are sharing the messages. So this is message passing. Right. So first of all, let us see about this message processing. The cooperative process, independent process cannot affect or be affected by the execution of another process, as we have already discussed. And cooperative process can affect or affected by the execution of another process, that is cooperative process, as we have discussed. So advantages of process cooperation: when you are using this process cooperation, you can use the advantage, take the advantage of information sharing, so that the computation can be speed up fast. Modularity, that is you can divide the task into several, and the convenience, as we have discussed, you can do multiple programs at a time. These are the convenience. Right. So in this, we have to discuss about producer-consumer problem. This paradigm for cooperating process. Producer process produces information, that is the consumer consumes the process. So here we are having two types of problems: unbounded buffer and bounded buffer. Unbounded buffer process places no practical limits on the size of the buffer. That is the reason we call it as unbounded. The bounded buffer assumes that there is a fixed buffer size. There is some limited number of buffer sizes there. So now, if we take the shared memory solution for the bounded buffer, the shared memory solution, here it will be like this. So this is the structure of shared data. So we are going to define the buffer size as 10, and here the structure of this buffer, and it is having the items. With the help of item, you are going to call this buffer item space buffer size, sorry, buffer of buffer size. The buffer size is fixed, it is 10. So int n is equal 0, this is one of the member, and out is equal 0, this is one more. So solution is correct, but only we have to use buffer size minus one element because it is bounded buffer. So here we have to consider producer side and consumer side. Both the side we have to take care. So producer will produce and consumer will consume, right? So what will be happened at producer side? So producer side, so this is, it is going to produce, next to produce item space, next to produce is one variable which, while true, so it is going to produce, when it is producing, so it is producing an item next to be produced, while here you are counting the buffer size, right? In place one, initially in is equals to 0. In previous slide you can see in is equal 0, out is equals to 0. So 0 plus 1 mod, that is 0 plus 1 is 1 mod, buffer size is 10. 1 mod 10 is, obviously it is 1. 1 is your answer. 1 is equals to out. 1 is equals to 0. It is not. So what will be happen? So do nothing. If this is 0, this condition true, do nothing. Else, so what it is going to do? So buffer of in is equals to, that is buffer of 0 is equals to next to produce. So that is buffer of 0 means it is completely size 10, right? So buffer of 0 means in this location, whatever the produced is there, that will be stored here, right? So in is equals to in plus 1. So that is, you are increasing the in value. In value is initially 0. Now you are incrementing it to 1 because in is 0 plus 1, it is 1. 1 mod 10. 1 mod 10 is equals to 1. So it is going to be, in will become 1, right? So this will be happened at produce side whenever it in is 1. So again it will go here 1 plus 1, 2 mod 10, again in value is 2, 2 is not equals to 0. So again it is condition will fail. So again it will come here. Then buffer of I, that means this position, whatever it is producing, it is going to store here. Then in the next cycle, it is going to produce here. Like that, it is going to increment its production. So what will be happen consumer side? So here one more variable created, that is next consumed. While true, while in is equals to out. So initially in is equals to out is equals to 0. So what will be happening if in and out is equals 0, do nothing, or else you do next consumed is equals to buffer of out. So what you have to do, consumed is a variable. In that variable, what you are going to do, buffer of out. So that will be stored here. Then out is equals to out plus 1 buffer size. So initially out is equals to 0. Now you are going to increment it to 1, then increment it to 2, then it will be 3. Like that, it is going to be increased. So every time you are taking this, you are going to consume the item in the next consume. So in the buffer side, producer side, you are going to produce, and consumer side, you are going to consume the element. So what will be happen in the inter-process communication? As we have discussed, there are two types of communication: shared memory and message passing. So what will be happen in the shared memory? An area of memory shared among the process that wish to communicate, whatever the area you want to share, that will be shared among the processes. The communication is under the control of the user's process, not the operating system. So major issues is to provide the mechanism that will allow the user process to synchronize their actions when they access a shared memory. So when it is having a pool of shared memory, so there must be a synchronization, just like producer will produce and consumer will consume. So like that, there must be a synchronization. If producer continuously producing, but consumer is not consuming any process, then if there is no synchronization, then it will be a problem. So this next one is message passing. So mechanism for process to communicate and synchronize their actions. They have to pass the message. So message system process communicate with each other without restoring to shared variables. So there are, for this process, there are two operations are there. One is send message and receive message. So the message is either fixed or variable. Message size is fixed or variable based on that scenario. Right. So what happened when the message is happening? If process P and Q wish to communicate, P and process wants to communicate. So what will be happening? So there will be established, a communication link will be established, right? So exchange messages via send or receive. There are two signals, send or receive. So via this send and receive, it is going to done. So implementation issues. So whenever sending messages, there will be some issues. So first one is how the links will be established. How you are going to establish the link. Can a link be associated with more than two processes? If you are having PQR and yes, so how you are going to communicate these fellows? So how many links can be there between every pair of communicating process? What are the links? How many links you have to establish? What is the capacity of link? Either it is a 2 process or 4 process or 6 process. What is the n number of process? And is the size of message that link can be accommodated fixed or variable? So whatever the link you are going to establish, that is fixed between the 2 process, or it is variable between the n number of process. That is one more issue. And is the link is unidirectional or bidirectional? Unidirectional is from P to Q or both the directions, P to Q and Q to P. So that is also, that issue also you have to answer. Right? So implementation of communication. So those are the issues in the communication establishment. So there are communication implementation is one is physical and logical. Physical is whenever you are giving the shared memory for the several processes. This is a shared memory you are going to establish. So this is physical. And the hardware buses, you can see the bus cables, network, whatever you are using, that is also communication establishment. So logical is direct or indirect, synchronous, asynchronous, or implicit or explicit buffering. These are the logical message passing. So for this direct communication, logical, in the logical one, first one is direct. So in the direct communication, process must name each other explicitly. So you have to name each other. Process must name each other. For that, send is a signal and receive is a signal. For that, it is having two parameters. That is, P is a process and the message whatever you want to send, right? So message is sending, P is sending message. So coming to here, Q is receiving message. Q is receiving message. So for that, receive is a function, send is a function, right? So properties of communication link. So what are the properties? Links are established automatically. Link is associated exactly with one pair of communication in the issues we have discussed in the previous slide. So between each pair exists only one link. And the link may be unidirectional, but it is usually bidirectional. So both the ways you can use this. So second logical one is indirect communication. So messages are directed and received from mailbox. So just like we are using the mails. So each mailbox is having unique ID and process can be communicated only if they share a mailbox. So properties of this communication link is link established only if process share a common mailbox, and a link may be associated with many processes. That is, one mailbox can be many processes can send messages to the one mailbox, right? So each pair of process may share several communication links. So links, again here also links may be unidirectional or bidirectional. Last one is indirect communication. Indirect communication is there are several operations. Create a new mailbox, that is you are establishing a port and send and receive messages through the mailbox like the previous one, and you can destroy the mailbox after completion of the communication for the security. And then there are some primitives, send message and receive message. These are the messages, and it will be having two arguments. Process A send a message to mailbox A and receive message from the mailbox A, like that is going to take. Right. So mailbox sharing, P1, P2, P3 are three processes which shares mailbox A. P1 sends, P2, P3 receives, and this is a shared one, right? In the indirect communication, you are P1 different process sharing and receiving, right? The solution for this is allows a link to associate with at least most two processes and only one process at a time to execute receive operations. Allows the system to select arbitrarily the receiver. Sender is notified who is the receiver was, right? So this is all about inter-process communication. In the next video, we will discuss about synchronization. Thank you.